Welcome everybody to today's London Java Community event. Thank you so much for coming. First of all, let me introduce myself. My name is Abby and I work with Barry Cranford, who's the founder of the LJC. I have the privilege of hosting the event today. For those of you who don't know, the LJC is just one of the communities that is run by RecWorks. We are a tech recruitment company with a huge difference. As a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. From our perspective, if people want to learn and others want to teach or share their knowledge, we are happy to connect you through our communities and events like this one. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run over 700 events for engineers and developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, mingles, all sorts. In January this year, we made our 4,000th introduction through our Meet a Mentor program, and we're really excited to see where that's going to go next. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you'd like to know more about any of our communities, please do get in touch with myself or Barry, and we can take it from there. The recording of today's session will be available on YouTube. I will put the link to our channel in the chat, but equally, if you want to message me on LinkedIn and I will send you the video when it's ready to go out, that's absolutely fine. As we go through the talk today, if you have any questions, feel free to put them in the chat, and some of them may be answered as we go along, but if they're not, then obviously Carsten will be able to answer them for you as we go. With no further ado, I'll hand over to Carsten and have a great event. And it's really great to see you all here. Carsten.
Hello, can you guys hear me? I take that as a yes. Yes. Okay, wonderful. And now you should see my title slide on that screen. Do you see that too? Sorry, can you just say it out loud? Because I'm in full screen mode. I don't see any.
Not yet.
Wonderful. Okay. So I'm sorry, what did you say? Not yet. Okay, because I didn't share my screen. That is a unfortunate thing. So.
Yeah.
Okay. And now the title screen, title slide. Can you see that? Okay. So. Well, first of all, thank you for the introduction. My name is Carsten Sales, and I'm here today to answer one question for you, which is, can we build mobile, web, and desktop front ends with Flutter and one Codebase? And the answer is, yes, we can. And I'll actually show you. But we really shouldn't, because I can only recommend Flutter on mobile, not on web and desktop. And I'll also tell you why. I also cannot, unfortunately, recommend the Java front-end frameworks that are out there today, and I'll also tell you why. So here's the agenda for today. First, I'm going to talk about why do we need cross-platform front ends and how can we actually build them. Then the main event of today is how Flutter works, my Flutter experiences, and then the moment you've all been waiting for, when should you use which framework? So you may ask yourself, well, who made me the expert? In a sense, I guess I did, because I put a Flutter app into the Google App Store, sorry, the Apple App Store and the Google Play Store. But, you know, that's what millions of people did. Beyond that, I'm a Java news editor at InfoQ, and I helped organize the Java and front-end tracks for KubeCon London that just happened, and KubeCon Plus happening next month. So I know about the industry. I've been a Java developer for 23 years, and even though I use Java, Angular, and Flutter, I'm not associated with these projects. I'm not a developer advocate. I'm not trying to sell you a book or training course here, right? What I'd like to think is that I actually give you options in my talk, but in the end, you decide, right? So If you want to get slides and more, then you can scan this QR code, or you punch in the URL directly, which is bpf.li/flu. I'll show this slide again at the end of my talk. So I'm moving on in 3, 2, 1, 0 seconds. Okay, on to the first part of the agenda, which is why do we actually need cross-platform frontends, right? And the answer is simple, because our users are multi-platform. Now, 30 years ago, when I started writing my first software for real, all we needed to do was writing a Windows application. Well, and then there's the Mac, and increasingly even Linux, right? Especially popular among developers. And mobile happened. So we've got iOS and Android. So it's really 5 different platforms out there. Now, we could try to write applications in their native platform SDKs, but, without even looking at that any closer, that's just too expensive. It's hard enough to hire developers these days, let alone trying to staff, 3, 4 different teams. That's just not economically feasible. So what we want to do instead is we want to have one framework and one language. Well, and we just happen to call this cross-platform. And that's really the reason why we need cross-platform frontends, because they're cheaper, right? They're cheaper than building with native SDKs, and they're good enough. Now, what do I mean with good enough? Good enough for me means enterprise and consumer apps. So I'm not talking about games. They've got separate frameworks. It's just, the run-of-the-mill applications that we all build in our day jobs, right? So, that's why we need cross-platform frontends, because they're cheaper. So now that we know why we need them, how can we actually build them? Okay, well, the default answer is we build them with web technologies. Why? Because the web technologies are the biggest software ecosystem that we've ever had. We've got the most developers there. Granted, it's a bit hard to learn. It's a lot. You've got HTML, JavaScript, or TypeScript. You've got CSS and tool stack like Node.js, NPM, Webpack, browser dev tools, so lots of stuff. But, we've got most developers there, so definitely it's doable, right? And there are 3 popular frameworks out there: React, Angular, Vue. So, that would be my recommendation for starting web projects these days. Now, you may say, well, we actually have something here in the Java world. Yes, we do, and it's called Jakarta Server Faces, but I can't recommend it. Why? Number one is we can't build single-page applications. React, Angular, Vue build these JavaScript, responsive, nice applications. We can't do that with Jakarta Server Faces. It's still, server-side rendering. It's been quite stale. Jakarta Server Faces hasn't had new features for 5 years. There are some new stuff coming in mid-22 with Jakarta E10, but still it's pretty stale. Angular has at least 2 major releases a year. React quite similar, and it's also very unpopular. You can go to the talk page to find details, but I've been looking at jobs around the world, and there are 14 times as many jobs for Vue as there are for JSF, 27 times as many for Angular, and 40 times as many for React. So not really popular. And if you look at Google searches or Stack Overflow questions, hardly anybody still cares about Jakarta Server Faces. But no matter which framework you use, if you use HTML, then this is what it's looking like, right? So HTML and CSS is how you build your user interface, and JavaScript or TypeScript is your language. So case closed? No, unfortunately not. We've got issues with web on mobile. So first of all, we've got some stuff missing compared to native application, especially on iOS, right? Apple kind of kneecaps Safari on iOS, and that's why we don't have push notifications or background sync on mobile Safari. No matter where you are on mobile, you're also somewhat restricted. For instance, you only have about maybe 50 MB of local storage for your web application, and you probably don't have access to all the native features of the platform. It's also often slower and less comfortable than a native application, and it just doesn't have that premium feel of the native look and feel. So why do I go on so much about native look and feel? Let me give you an example of a German online banking app. I'm German and I happen to use this application. So here you see the web application on the left, and they recently started migrating to a native application on the right. So what's different about this? Well, number one is you can see the web application has this hamburger menu in the top left. This is actually hard to reach, and it's not obvious. Well, at least not obvious to my mom, right? So how do you know you can tap on these three dashes? And it's always two taps, right? It's one tap for the hamburger menu and then one tap for the functionality that you want to reach. Now, the native application, on the other hand, has a nav bar. It's easy to reach. It's obvious because many applications have this nav bar, and it's one tap for most used features. If you look closely, you see there's these little twisties there on the web page, right? Now, these little twisties, they're actually user interface elements, but again, they're not obvious. How do you know that you can touch those? My mom would probably find it easier to touch, to tap these large cards here because, they look like other applications. And so, this is stuff you can touch on. And I think that subjectively, I would say the app on the right, the native app, just looks nicer. So native look and feel, it's easier to use because it looks and feels like all the other apps on your phone, and it also looks nicer. As it just happens, Google actually agrees with me because for all their apps on iOS, they're moving from Material UI to native iOS UI. And here's a quote from the responsible manager. Okay, so Google thinks that in order to look and feel great on Apple platforms, you have to use the native look and feel. Okay, now if we do that, then we actually have two cross-platform stacks now, right? Because we're keeping our web stack for PC, and then we're adding the native cross-platform one on mobile. Now, so far I've used the term native, and I'd like to clarify that a bit because I actually see three different things under this label. The first one is the application runs natively. So you can find it in the App Store. It's an app. It's not a web page, right? So that's the first thing, runs natively. The second thing is native look and feel. We just discussed that. And the third one is that you have access to native functionality, cameras, pictures, location, Bluetooth stack, this kind of stuff. So all these three things running natively, native look and feel, and access to native functionality, that's what I define as native. Now, given those criteria, what kind of native cross-platform frameworks are out there? Well, I'm looking for open source one and Java-like ones. After all, I'm a Java guy. So I came up with 4. First one is Flutter from Google. The second one is React Native from Facebook/Meta. We have Xamarin/.NET MAUI from Microsoft. Xamarin is the old name. It's currently being rewritten as .NET MAUI. MAUI is not just an island in Hawaii, but also stands for Multi-Application User Interface. It's scheduled for Q2 this year. And then we've got the venerable JavaFX, used to be part of Java until Java 11, I believe, and now maintained by a company called Blue. Now, I'm interested in which framework is popular. Why do I care about popularity? I think picking a popular framework makes it easier to learn and use that technology. There's more articles out there, more training materials, more online courses, more questions and answers at Stack Overflow. It's also easier to convince your teammate and boss, and I'll talk about that in a second. So I think popularity can make a difference in 2 situations. When all else is equal, you can say, hey, let's pick the most popular framework here. Or if something is very unpopular, you may not want to use that. As it just happens, I actually measure technology popularity for my newsletter, and I want to show you 4 different popularity indicators here. The first one, and I think the most important one, is how popular is a technology with employers. So I measure that by looking at how often a technology is mentioned at Indeed.com, which is the biggest job portal in the world across 62 countries. So that's pretty much every country that Indeed operates in. Why do I think that's important? Well, if you go and propose a new technology in your job, your teammates, if they act rationally, and I hope they do, they will immediately ask themselves, can I find a job with that technology? So they're going to go to a site like Indeed.com and punch it in and see how many jobs are out there for that particular technology. Now, your boss will probably do the same as well, right? Because he's worried about, can I hire developers for the technology? And his way of finding out is the same thing. He goes to a job portal and he looks. And if there's nobody looking for that technology, if there are no job ads, and he say, well, if there are no job ads, there are probably no developers either. Maybe there's something wrong with this technology. So that's why I think, job ads are very important. So without further ado, I've been monitoring that since August of last year on a monthly basis. And so let's get started. So React Native had 19,200 mentions across the world last August, and it's now up to 25,800 just a couple of days ago. Sunday actually is when I took that measurement. Now you see these percentages underneath. What's that? Well, in order to see how technologies compete against each other, I'm taking the runner-up technology as the baseline at 100%. And that allows me to see whether the leader is pulling away and how the other technologies, whether they are catching up or not. So Flutter, 100% always, because it's the baseline, went from 8,400 to 10,400. Then we've got Xamarin, which started with 5,200 mentions and is now at 5,800. Kind of roughly where it was last August at about 60% of Flutter mentions. And then we've got JavaFX, which started out with 2,000 mentions and is now at 600 worldwide. I think the first two measurements that you see on the left from August to September, I think they were a fluke. So I think the 7%, the 500 mentions starting with October is the real number. So takeaway is, since last August, React Native added 6,600 job ads, Flutter 2,000, and JavaFX just 200. Next stop, developer popularity. Looking at how many courses were bought at Udemy, one of the, if not the biggest online training sites. And I think that's another good indicator because it shows you where developers spend money on training, which I think is a better signal than checking out how many free courses somebody's taken. So I've been monitoring that longer, since March of last year. And here Flutter is in the lead, starting out with 1 to 3 million students in March of last year and getting up to 2.1 million students just on this Sunday, last Sunday. Here React Native is the runner-up. That's why at 100%, going from 800,000 to 1.1 million. Xamarin here, a lot lower, just a quarter of React Native's volume, increasing by about 40,000. And JavaFX putting up a bit of a surge, going from 109,000 to 183,000. But, comparatively little compared to, React or Flutter. So takeaway is, in this little bit more than 1 year, Flutter added 800,000 students, React Native 320, and JavaFX 74,000. Next up, developer popularity with Google searches. You can find the links there on the talk page, so you can do that yourself. So we see JavaFX peaked in December 2008, Xamarin peaked in March 2017, React Native peaked in July 2019, and Flutter peaked last month. So if you take a look at the numbers, so currently Flutter has 99% of the questions, or the searches, React Native 53, and JavaFX 7. Last point here, developer popularity, questions at Stack Overflow. JavaFX, we see it peaked at the end of 2018. Xamarin, number 3 on this chart here, peaked at the end of 2017. React Native, number 2, peaked at the end of 2021. And Flutter peaked at the beginning of this year. So if we look at the percentages of questions, then we currently have Flutter at 2.18%, React Native at half of that, 1.42%, and JavaFX at a fraction of that, around 1.3%. 80% of all questions on Stack Overflow. Now, let's sum up the popularity. We see that employers love React Native. React Native wins by 2.5x over the second one, Flutter, and is actually pulling away from Flutter. It's the other way around with developers. Flutter wins by 2x margin over React Native, and itself is pulling away from React Native. Now, if you're interested in finding out the same kind of measurements for JVM languages, frameworks, databases, or web frameworks, then you can subscribe to my newsletter where I measure this popularity for these 4 other areas every month. So let's sum up what we've learned so far. Web is the biggest software ecosystem that we ever had. It has the most developers. It's a bit hard to learn, but the frameworks to recommend are React, Angular, Vue, Java, Jakarta, server faces I do not recommend. Now, we need native sometimes on mobile that is running natively, having a native look and feel and access to native functionality, especially on mobile. That's where it's at. And there, Flutter is loved by developers, but employers prefer React Native by a wide margin. There's also Xamarin / .NET MAUI and JavaFX. So that's how we can do cross-platform frontends. Now, let's look at how Flutter actually works. But before we do that, this is the mascot of Flutter and Dart. A mascot is called Dash, and it's supposed to be a hummingbird. Now, Flutter is a project sponsored by Google, and that means everybody's going to be asking the same question. Ooh, that was brutal, wasn't it? So, will Google kill Flutter? Well, this is actually serious because it's a hard-earned reputation. There are websites that track the projects and services and things that Google killed so far, and this website here counted 266 as of last Sunday. So, will Google kill Flutter? And the answer is, of course, we don't know, right? What's bad for this question is there's in-house competition. Angular is a popular web framework sponsored by Google. And if you look at the Angular webpage, it says, and I quote, for web, mobile web, native mobile, and native desktop. So that's really what Flutter does as well. So if you're a developer, you don't know, should I use Flutter or should I use Angular, right? So there's a bit of confusion. And then, of course, we've got Jetpack Compose, which is Flutter for Android. So if you just want to build Android applications, you don't need Flutter. You can use Jetpack Compose, kind of the same thing, roughly speaking. Now, what's good for us if you want to use Flutter is that Flutter has external commitment. So Toyota uses Flutter for car infotainment systems, and Canonical currently rebuilds the Ubuntu apps with Flutter. So that's good. And as we saw, it's popular with developer and at least in second place with employers. Now, Flutter supports multiple platforms. How long have they been stable? Mobile got there first. So on iOS and Android, Flutter has been stable since 2018, December 2018, for 3.5 years, mostly. The web went stable last year, a year ago. On Windows went stable just 2 months ago in February this year, and Mac and Linux are supposed to be getting stable, hopefully this year. Now, Flutter uses a programming language called Dart. Dart isn't really used anywhere outside from Flutter. So, we're Java developers and we say, crap, why do we have to use, why have to learn a new language? Can't we just use Java? Because, in the end, all we want to do is write, Java code like that. Now, if you look closely, you see this isn't actually Java code. This is Dart code. It looks like Java, but there's one place where you could see this isn't Java. And so I'll show you. Yep, just that little list initialization is all, that's different between Java and Dart code. And so you see that Dart on purpose was built to be similar to Java and C#, to ease developers getting into Dart. Now, let me switch back to Dart. Yes, technically, this is Dart code. It compiles, but you wouldn't write Dart code like that. You would write Dart code that looks like this. So you can see it's a lot more concise than Java, right? There's simpler variable declaration and initialization, and you can write simpler methods. Again, let me compare to Java. So, you see Java is a lot more verbose. So what is Dart? Now that we've taken a look at it, Dart was originally built for the browser, but it didn't succeed there. JavaScript was too strong, but now it's being used in Flutter. As you've already seen, Dart is a simplified Java for UI development. And even though it's simplified, it has features that Java doesn't. For instance, it has sound null safety, so better than what Kotlin has, and that means less null pointer exceptions. Yay! It also has async await for concurrency, the same way that Java has that, JavaScript, so concurrency is also easier in Dart. Like many frameworks, pretty much everything happens on the main thread, but you can create your own threads. They're called isolates in Dart. In my application, I didn't have to do that, and still, doing everything on the main thread, still my application is pretty fluid. Now, Dart and Flutter, they get released at the same time. So whenever there's a new Flutter release, there's about 3 or 4 each year, there is a new Dart release, and Google essentially controls both Flutter and Dart, and that allows them to tune Dart for Flutter. Let me give you an example of the kind of syntactic sugar that Google can put into Dart just for Flutter. So here's some Flutter code where you create a column, so 3 elements on top of each other, 3 text fields, first name, last name, and a password. Now, if you look closely, you see this if is admin thing here. So what's that? Well, it is what you probably think it is, which means the password is only being shown if the user is an admin. And this if is admin condition is put right into the list initialization. So that's simpler than having a separate list declaration and then an if statement and saying, hey, append the password if the user is admin. So it's, it's not earth shattering, but it's a little, syntactic sugar element here to keep your code concise. And that's the kind of syntactic sugar Google can put into Flutter because it controls both Dart and Flutter. Libraries are called plugins in Flutter. There is a portal for them, nice one, much nicer than Maven Central. If you go there, you see there's about 23,000 plugins. Most of them are for mobile, not all of them are for web and desktop. Most of them are open source. And in my experience, they've got a good plugin survival ratio. So in the 1.5 years that I built my production app with Flutter, none of my plugins that are relied on got abandoned. And there's even a team of developers that take care of platforms that are important to the ecosystem. And if you ever find an issue with a plugin or the plugin doesn't do what you want, you also have the options of just forking it and then putting the Git repo URL directly in your build file. So it's a lot simpler to fork a plugin than it is to fork a Maven dependency, because you can just put in the Git URL. No need to push it to a repository first. UI elements are called widgets with Flutter. And the important thing is that, as you can see here, we write UI as code. So there's no graphical UI builder, no CSS, no XML files. We write our elements, a column for vertical alignment, and then text and button. We write them as code, and we configure them as code as well, as you can see here. So, which is pretty good if you're backend developers, which most of us Java developer guys are. So widgets. So you spend most of your time configuring the built-in widgets that come with Flutter, or you create your own widgets. I do both. The most important thing to know about widgets is that they do not use the native SDK UI elements. Instead, Flutter emulates them, right? And it uses the Skier graphic engine for that, 2D engine, which is used by Chrome, Firefox, and Android. So again, Flutter paints pixels. It doesn't use the native UI elements, so the text fields and buttons and everything out there that you see in Flutter is painted by Flutter. It doesn't use native UI elements. For look and feel, you get the widget sets, and there's 3 different ones. There's a base set that works everywhere, like container, like row, column that you see in there, or text image. Those are the same no matter which platform you are on. Flutter ships with 2 built-in widget sets, Material UI, Material Design, I'm sorry, that runs everywhere and is the native look and feel on Android. And then there's the iOS look and feel for iOS and iPadOS. Third parties can contribute their own look and feel. So for instance, macOS, Windows, and Linux, those are third-party look and feels. And I've got a treat for you here, a sample Flutter app that I created just for this talk, where I have 5 native look and feel with 1 code base. And if the demo got smile in me, you're going to see that in a demo now. Okay, so let's get started here. What you see here is the application running, and I have to look up because that's where my screen is, the application running in the iOS simulator. It's a typical iOS application. So if I put in my first name, you see the label disappearing. I've got a simulated dialog here, which is, a iOS dialog. Now, as I said, Flutter paints pixels, which means that if you put that into your application, you can actually switch the look and feel. And so now I'm switching to Android. So even though I'm still running in an iOS simulator, I now have an Android look and feel. So as you can see, the first name, the label stays with me, and the dialog looks different because, it's Android, right? And now let me minimize that and go here to my web application. So this is Flutter running in a web application. The UI is Material as well. You can see that. And we've got the hamburger menu, the apex of user interface design on the web. Now, let's do the same thing here. Let's switch and say, even though this is a web application, we want it to look like a Windows application. And so you immediately see you've got a sidebar here. If you make it a little bigger, then you see it actually expands. We've got a form, and the form looks like a Windows modern UI look. And you see a Windows dialog here. And then let me do the last part here, which is switching to macOS. You see there's a bug here, which I believe is a bug with Flutter. But again, here we have a form. Again, it's a modern Mac UI form. Labels disappear, and the save button is a Mac button. Okay, so back to the presentation. So what did we see? Well, we saw that we had 5 different native look and feel. We had iOS, Android, Material on the web, Mac, and Windows, and we could switch between those. And we could switch between those because Flutter just paints pixels. It doesn't use the native UI elements. And if you were to take a look under the hood of the web application in the DevTools, then you would see that even though on the left you see the text fields and form fields and buttons, on the right, if you drill deep down, all there is just a canvas. So from the web application, from the browser perspective, it's a canvas, and then Flutter just paints on that canvas. So no native elements being used. The sample app is on GitHub, and you can find the link on my talk page. Now, I said that the app switches between different UI elements, look and feel. How does that work? Well, probably the way that you expect it to. I created my own widget. The widgets have a switch statement, and in that switch statement, my app says, hey, if I'm on iOS, then use iOS look and feel. If I'm on Android, use Android look and feel, and so on. If you build an Flutter application, you have to make 4 different architectural choices. The first one is, how do you manage global state? The built-in solution is called Provider. I use Redux in my application. Then you have to figure out what kind of widget set do you use. Do you use Material, Native, or Custom? I use Native with some custom in my application. Routing, getting from screen to screen. There's a simple routing solution built in called Navigator, which I use and which is perfectly fine. A more complex one is called Router, and I've never used it. Now, for responsive layout, adapting to screen sizes or orientation on mobile, there's nothing built into Flutter, so you have to rely on third-party plugins here. I use a plugin that takes the Bootstrap grid and converts that into into Flutter. Native integration really means two different things. Number one, running Flutter in native apps. That's actually possible. It's stable on iOS and Android. And the example that Flutter team gives is the WeChat application, one of those big Chinese applications that do everything. They added a bunch of screens in their native iOS and Android application with Flutter. So you can do that, augment your existing iOS or Android application with Flutter screens. As far as I know, that's not possible on the web and desktop. I think they're at least working on web, but not on desktop, and it's not finished either. Now, especially on mobile, what you'll do more often is to have native code run in Flutter. And so for the most part, you just use plugins. So if you want to use the camera or want to have access to pictures, locations, stuff like that, then you don't have to write native code. You use a Flutter plugin for that. What a Flutter application can also do is showing native screens. So that's, for instance, what the Google Maps plugin uses, because it shows a native Android Google Maps screen on Android and the native iOS screen on iOS. Your app can also show a web view. So, you've got, the world is your oyster there. Now, if you want to communicate more with native code, then you've got channels, which is asynchronous publish and subscribe mechanism on Flutter, so that your Dart code can call into Swift or Kotlin, or Swift and Kotlin code can asynchronously call into Dart code. And there's even a C API if you need to do more than that. Now, I said that Flutter runs natively. So how can it do that? How can it run natively on the web or the desktop or on mobile? Well, it relies on platform tool chains, right? So if you want to run on Android, then you have to use Android Studio, which fortunately runs everywhere. If you want to build applications for iOS or macOS, you need Xcode on macOS, Apple's free IDE. And if you want to build a Windows application, you have to run Visual Studio, not Visual Studio Code, the real Visual Studio for Windows on Windows. Fortunately, the free community edition does, so you don't have to shell out money here. Now, when you compile and deploy your application, then the Flutter engine gets deployed as JavaScript and C++ on the web, and just as C++ everywhere else, compiled C++ into native code. Now your app gets deployed as a native ARM library on mobile, as JavaScript on the web, and as C++ on Windows on Linux. On macOS, it gets deployed as Objective-C, which is Apple's version of C. Now, code build and deploy is something that the Flutter team paid special attention to. Why? Because they want to have an excellent developer experience as a way to differentiate from other frameworks. And I think they're successful. And I think that's part of the reason why developers prefer Flutter over React Native. You just have a better tools and development story, I think. Now, code, what kind of IDEs can we use? The two that are officially supported are IntelliJ or Android Studio and Visual Studio Code. Flutter also ships with dev tools like an inspector, a profiler for memory, CPU, and network. And the important stuff is that these tools do not only work in the IDE, they also work when you just launch your application from the terminal, because they're implemented as a Flutter web application. And let me show you two screenshots here of the dev tools. So here we have the Flutter inspector, and you see there's a button selected here on the left, and we see it in the widget tree, and below we see the properties of that. So that's very similar to what you get with the web development tools, right? And here we have the CPU profiler with a flame chart, and we can use that, in real time to dial into the application and see where do we spend all our CPU power here. So what kind of projects does Flutter create? It creates a mono repo with the code for all platforms in just one Git project. So no matter how many platforms you have, everything is just a single Git repository. You get one folder for Dart and then one folder for platform. And in some projects, like in Android or iOS and macOS, those folders are actually projects, like an Xcode project or an Android Studio project. Now, each platform has a native shell that launches your Flutter application, and that's where you can then put some customizations in. So on the mobile side, which I happen to know, you've got an app delegate Swift file or main activity Kotlin file, just like you do in regular iOS or Android development. Flutter has a fast build and deploy, which is especially important on mobile. Why? Because on mobile, build and deploy is slow. You could easily spend 30 seconds or a minute or two waiting for your updated app to be deployed, because it always gets compiled into native code. Now, Dart, on the other hand, uses a virtual machine during development. So in that regard, it's similar to modern Java frameworks like Quarkus, which use a virtual machine during development, but deploy to native code with GraalVM. And that virtual machine gives us two features. Number one, a hot restart, which means the entire application is reset and going back to the starting point. And that takes about 3 seconds. But the coolest feature is hot reload, where it just takes 1 second from you pressing save until the app is updated and running in the simulator or on the phone. And my talk page has a video demonstrating that. Now let's take a look at the Flutter platforms and how they are supported. So on mobile, I give Flutter a thumbs up because in essence, you get 2 apps for the price of 1. You get native look and feel, access to all the native libraries and features, but with a faster build and deploy than native development. On the web, I'm giving Flutter a thumbs down. Why? Because it only supports Material UI. You don't get access to the platform libraries, which are JavaScript. And because you only have access to the Flutter plugins, not the hundreds of thousands or millions of JavaScript libraries out there, you just have a tiny amount of libraries available to you. On the desktop, I'm also giving Flutter a thumbs down. Why? Because number one, you probably shouldn't be developing web application, desktop application, because web applications are fine, right? Your users are used to web applications, and web browsers have less restrictions on the desktop. For instance, you've got push notifications on Safari as well. Now, if you want to go ahead and develop on the desktop, then only Windows is currently stable there, not macOS and Linux. You do get access to native features through a C++ interface, but the widget sets for native look and feel are incomplete. For instance, macOS doesn't have a dropdown. And it's a huge task to keep this up to date, so I'm not sure that'll always be the case. So let me sum up. Dart is a simpler Java tuned for UI. Plugins are the libraries of Flutter, and they're easy to work with. The widgets are the UI elements. They are emulated. Widget sets are the look and feel. Flutter ships with Material and iOS, and third-party provide desktop look and feel. You have access to pretty much all native functionality on mobile devices. Flutter runs natively because it compiles to native code with the platform toolchains. Code, you get a pretty good experience there with great development tools, a mono repo for all the platforms, and a fast build and deploy on mobile. And finally, in the platform check, Flutter shines on mobile, not on web desktop. So that's how Flutter works. Let's quickly tell you about my Flutter experiences. I'm a co-founder of a startup where we do a business-to-business software as a service for cat sitters. Yes, cat sitters. Our business value is that we remove friction and save time, and I wrote all the code. Our backend is Java with Spring Boot and a Postgres database. We use Firebase for authentication and files, and I'll talk about that in a second. The managers use an Angular web application, and the cat sitters use a Flutter app for iOS and Android. Why did I pick Flutter? What was the business case here? Well, first of all, I didn't want any restrictions. So unlimited storage, more than just a 50 megabyte of a browser, push notification, stuff like that. Because our business value is removing friction, I wanted the app to be as fast and user-friendly as possible, which meant having native look and feel. And with the prototype, I evaluated Flutter nearly 3 years ago, and I found that between the fast code build and deploy and Dart being very similar to Java, I was really productive. So I picked Flutter. Now, Flutter on mobile, thumbs up. It really works. 2 apps for the price of 1. Yep. There are some minor quibbles, like something the app doesn't stop in the simulator, nothing to worry about. If there's something wrong, then typically it's Apple breaking Flutter. So for instance, for the past couple of months, you cannot paste from the clipboard into a Flutter application running in a simulator. Apple broke that in the simulator. And the Flutter team listens, so they do lots of bug fixes, and there are quarterly developer surveys. Now, I said Flutter paints pixels, everything is emulated, and I think it works well on iOS. There's some quibbles, like there is no native list tile implementation for iOS. And the Flutter team tells you don't use native look and feel, but rather customize Material UI. So you're on your own there if you're dealing with native UI, but you can manage. So let me give you some examples here. So on the left, we've got my app on iOS. On the right, we've got it on Android. And if you know your way around mobile, you see some of the differences here. For instance, on iOS, you've got a button in the app bar, and on Android, it's a floating action button. And on iOS, the lists have a chevron on the right to indicate that you can tap, and on Android, they don't. Some more details here. On this screen, we have a segment control, which is a more recent UI element that Apple added. And then here I told you there's no native list implementation, so I coupled one together based on some plugins and my own code. And it looks pretty close to what a list would look like on iOS. So that's a custom widget that you're seeing there. But, I also share stuff between platforms. So these buttons look exactly the same between iOS and Android. And so do these cards on the task home screen. So they're exactly the same in iOS and Android. I also use Firebase, which is Google's backend as a service for mobile, web, and server. It's mostly free. For instance, authentication, analytics. You do pay when you want to store data, so database and file storage. I use file storage. You have to pay. Especially on mobile, it's quite nice because you often have 2 different services to do the same thing, like crash logging and test version distribution. Both iOS and Android have their own way of doing that, and Firebase gives you just 1 service there instead of 2. And yep, works as designed and has good Flutter integration. You find more stuff on the talk page if you care to go deeper into that. So for instance, how to use the power of mobile devices, how you can keep your UI correct with 1 source of UI truth, how I try to be consistent between the web app and the mobile app, and that back to basics also applies to mobile apps. So those were my Flutter experiences. Now to the $1 million question, when should you use which native cross-platform framework? But before that, let me sum up what we talked about so far. So why do we need cross-platform frontends? That's a mouthful, isn't it? We need it because they're cheaper and they're good enough for the apps that we are building. How do we build cross-platform frontends? The default should be the web because it's the biggest ecosystem with most developers, and React, Angular, and Vue are your frameworks there. Jakarta Server Faces isn't really of the times anymore. Now you have to go native sometimes because you want to run natively on mobile, have native look and feel and access to native functionality. Then developers prefer Flutter, employers prefer React Native, and then there's .NET MAUI and JavaFX. We talked about how Flutter works. Dart is the simpler Java tuned for UI. Plugins are your libraries. They're easy to work with. Widgets are the UI elements. They're emulated. Flutter ships with the Material and iOS look and feel, and third parties give you desktop look and feel. You've got access to pretty much all native functionality on mobile. Flutter runs natively because it compiles to native code with the platform toolchain. You got great development tools, a monorepo for all platforms, and a faster build and deploy on mobile than native development. And when you look at all the different platforms, then Flutter shines on mobile, not on web and desktop. My Flutter experiences The business case is to overcome restrictions, have a fast UI, and be productive. Flutter works, 2 apps for the price of 1. Flutter paints pixels, that also works. And Firebase works as well. So now let's compare Flutter versus the world. If you take a look at React Native versus Flutter, the 2 big competitors here, React Native uses JavaScript, Flutter uses Dart. React Native is generally slower because at runtime there's interpreted JavaScript, whereas Flutter is faster because it compiles to native. Flutter has a native UI elements. React Native uses the native UI elements. Flutter paints pixels. They are emulated there. With React Native, you've got at least 2 separate projects, one for web, one for mobile, React and React Native. With Flutter, you get a monorepo, and the desktop support in React Native is unofficial. There are forks of React Native for Windows and macOS, but Flutter officially supports all desktop platforms. Now let's look at popularity, Flutter versus JavaFX. With jobs, there are 17 times as many jobs for Flutter than there are for JavaFX. There are 11 times more students for Flutter, 14 times more searches, and 20 times more questions on Stack Overflow. Now let's look under the hood a bit. JavaFX uses Java, Flutter uses Dart. JavaFX uses a builder tool. Flutter uses UI as code, which is the more modern approach, I would say. There is no native look and feel with JavaFX, but there is with Flutter. I think in JavaFX, you've got limited access to native features, but you've got full access with Flutter. The web is immature in JavaFX, support for web platform. And with Flutter, it's the desktop platform. That's not fully there yet. So when should you use which native cross-platform framework? Let's answer it. Well, I would go by developer experience. If you're a web developer, then you go with React Native. If you're a .NET developer, then go with .NET MAUI, which is a release candidate stage right now. If you are a Java developer and you've got legacy Java libraries that you want to use, you really have no option but to use JavaFX. But for everybody else, which means Java developer that don't have Java legacy libraries as well, they can use Flutter. So back to the big question that I posed at the very beginning. Can we build mobile web and desktop frontends with Flutter and one codebase? And yes, we can. But we should, because I can only recommend Flutter on mobile, not on desktop and web. Why? Because on mobile, you get 2 apps for the price of 1 that can do everything that mobile apps can do, but with a faster build and deploy. Web only has Material UI for the widget set and very few libraries compared to React, Angular, Vue. Desktop probably shouldn't write a desktop application, and if you want to, then only Windows is currently stable. I cannot recommend Java front-end frameworks generally. JSF doesn't allow you to build single-page application, has no new features for the last 5 years, and is unpopular. And JavaFX uses a UI builder, doesn't have native look and feel, limited native features, and is also unpopular. So that finishes my last agenda point here, which means it's the end of my talk, but my talk doesn't stop when I stop talking. So on my talk page, you find the slides and videos, additional information, the link to the native sample app that I showed you earlier, links to getting started with Flutter, and feedback and newsletter as well. So that's it. I'm done with my talk. So does anybody have any questions?
There were a couple of questions posted in the chat cast, and before I say anything else, that was brilliant. Thank you so much. That was really interesting. I'm sure you guys all found it interesting as well. So you may have already answered this. It might have been covered earlier on, and we may need to obviously have a look back at the recording to really answer it. But how can Java developers incorporate Java backend with Flutter front end?
probably the same way that you would do it in a single page application with REST API calls. So in my case, both my Angular application and my Flutter application, they use the very same REST API into my Spring Boot application. So it's JSON REST API that's natively supported on Angular and Flutter. So I've got good experiences with that. There's probably other options like GraphQL or some other stuff, but for me, the JSON REST API worked just fine.
Cool, excellent, thank you. We've also had a question. You used the term good enough, but do the apps meet the high standards of look and feel for both iOS and Android?
That's a good question. I would say yes. Why do I say that? Typically, the alternative that developers have is not, do we build a native iOS and Android app, or do we build a Flutter or React Native app? Typically, it's do we keep our web application or do we do something else? So from that perspective, a Flutter or React Native app, is miles better than a web application. Now, I'm pretty sure that, there are some small parts where a experienced developer would see, hey, a Flutter application doesn't use the native UI elements, but the animations and everything is pretty much spot on. So I'd say, yep, it's good enough for, I want to say 99% of the people. I'm sure there's 1% of developers that give you grief on Twitter because, it's not native, but, Twitter isn't the real world. So, yep, I think it's good enough.
Excellent, thank you. Does anybody else have any further questions before I bring us to a close? I will take that as a no. So all that's left for me to do now is to say thank you once again, Carsten, for coming to speak to us. That was really interesting. And to thank all of you for joining us this afternoon. And like I say, you can find the recording on the London Java Community YouTube channel or message me on LinkedIn and I'll be able to send it over to you. So we're getting lots of messages, Carsten, saying thanks very much, great talk, really enjoyed it. So thank you very much, everyone, for coming. Have a great afternoon. Enjoy. Take care.